Yes, the existing service disconnects can be used as the disconnecting means for the induction heater control cabinets as long as certain conditions are met. Firstly, line of sight is essential. The existing service disconnects must have a clear, unobstructed view of the associated Hubble twist lock connectors. Secondly, the disconnects must be lockable. The existing service disconnects must be capable of being locked in the open position to ensure safety during maintenance or servicing. There are additional considerations. Proximity is important. The Hubble twist lock connectors should ideally be installed within 50 feet of the existing service disconnects. Accessibility is also key. The Hubble twist lock connectors should be easily accessible for connecting and disconnecting the portable unit. Labeling is necessary for clarity. The Hubble twist lock connectors and the associated control cabinet should be clearly labeled to indicate their purpose and the location of the corresponding service disconnect. Verification is needed to ensure compliance. Firstly, measure the distance between the service disconnects and the Hubble twist lock connectors to ensure they are within the 50-foot requirement. Secondly, inspect the service disconnects to confirm they have a provision for locking them in the open position. Document all findings in the maintenance records for future reference. It's important to note that if any of the control cabinets are located more than 50 feet from the existing service disconnects or do not have line of sight, additional service disconnects will need to be installed, as required by Section 665.63 of the National Electrical Code. Section 665.63 addresses the disconnecting means for induction and electric heating equipment. It specifies the requirements for a readily accessible disconnecting means that can safely de-energize the equipment for maintenance or in case of an emergency. This section mandates that the disconnecting means be either within sight from the equipment or capable of being locked in the open position. The phrase line of sight implies that the disconnecting means is visible and easily accessible from the equipment it controls. This allows personnel to quickly and safely disconnect power to the equipment in the event of a malfunction or during servicing. Alternatively, if the disconnecting means is not within line of sight, it must be designed to be locked in the open position. This ensures that the equipment cannot be inadvertently re-energized while someone is working on it. The lockable feature typically involves a mechanism that allows a padlock or similar device to be installed, preventing the switch or breaker from being closed. The 50-foot proximity recommendation enhances safety and convenience. By keeping the disconnecting means relatively close to the equipment, personnel can quickly access it in case of an emergency. This also reduces the risk of confusion or delays in identifying the correct disconnect. The labeling requirement is crucial for clear identification. Properly labeled disconnects and equipment minimize the chance of errors during operation and maintenance. The label should clearly indicate the purpose of the disconnect and the specific equipment it serves. The verification process is essential for ensuring ongoing compliance. Regular inspections and measurements help identify any potential issues or deviations from the code requirements. Documenting these findings in the maintenance records provides a valuable reference for future inspections and repairs. When selecting and installing Hubble twist lock connectors, consider their amperage rating and voltage rating. The connectors must be rated to handle the full load current and voltage of the induction heating equipment. Ensure that the connectors are properly installed and grounded to prevent electrical hazards. Regular inspections of the connectors are recommended to check for any signs of wear, damage, or corrosion. If any issues are detected, the connectors should be replaced immediately. For Square D safety switches, verify that they are properly rated for the application. Safety switches are designed to provide a reliable means of disconnecting power to equipment. They typically have a visible blade that indicates the switch position. Ensure that the safety switch is installed in a readily accessible location and is properly labeled. For 3-pole panel mounted breakers, ensure that they are correctly sized for the load and are installed in a properly rated panel board. Circuit breakers are designed to automatically trip and interrupt the flow of current in the event of an overload or short circuit. Regular testing of the circuit breakers is recommended to verify their functionality. If the induction heating equipment operates at a voltage greater than 600 volts, additional safety precautions may be required. Consult with a qualified electrician to ensure compliance with all applicable codes and regulations. When installing the disconnecting means, consider the environmental conditions. If the equipment is located in a damp or corrosive environment, use enclosures and fittings that are specifically designed for those conditions. Proper grounding is essential for electrical safety. Ensure that all equipment is properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards and equipment damage. Regular maintenance of the induction heating equipment is crucial for ensuring safe and reliable operation. Follow the manufacturer's recommendations for maintenance procedures and schedules. Any repairs or modifications to the equipment should be performed by qualified personnel. If any control cabinets are located in areas with limited access, consider installing remote disconnecting means. This allows personnel to de-energize the equipment from a safe and convenient location. When using portable induction heating units, ensure that they are properly grounded and are connected to a properly rated power source. Do not overload the power source or use extension cords that are not rated for the application. Always follow the manufacturer's instructions for operating the portable unit. When performing any electrical work on the induction heating equipment, always de-energize the equipment and verify that it is safe to work on. Use appropriate personal protective equipment, such as gloves and safety glasses. Never work on energized electrical equipment unless you are qualified and authorized to do so. If you are unsure about any aspect of the installation or maintenance of the induction heating equipment, consult with a qualified electrician or engineer. They can provide guidance and ensure that the equipment is installed and operated safely and in compliance with all applicable codes and regulations. The use of hubble twist lock connectors can provide a convenient and reliable means of connecting and disconnecting portable induction heating units. However, it is essential to follow all safety precautions and code requirements to ensure that the installation is safe and compliant. Always prioritize safety when working with electrical equipment. Taking the time to properly plan and execute the installation can help prevent accidents and ensure the long-term reliability of the induction heating equipment. Remember to consult the latest edition of the National Electrical Code and any applicable local codes and regulations. These codes provide detailed requirements for the installation and maintenance of electrical equipment. By following these guidelines, you can ensure that your induction heating equipment is installed and operated safely and efficiently. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before performing any electrical work. Understanding the principles of induction heating can also contribute to safe operation. Induction heating is a process that uses electromagnetic induction to heat electrically conductive materials. The material to be heated is placed inside a coil that carries an alternating current. The alternating current creates a magnetic field that induces a current in the material. This induced current generates heat due to the material's resistance. Induction heating is a highly efficient and precise heating method. It can be used to heat a wide variety of materials, including metals, semiconductors, and ceramics. Induction heating is commonly used in applications such as heat treating, brazing, soldering, and melting. When working with induction heating equipment, it is important to be aware of the potential hazards. These hazards include electrical shock, burns, and exposure to electromagnetic fields. Always follow the manufacturer's instructions and safety precautions when operating the equipment. Ensure that the equipment is properly grounded and that all safety interlocks are functioning correctly. Never operate the equipment if it is damaged or malfunctioning. If you have any questions or concerns about the safety of induction heating equipment, consult with a qualified expert. They can provide guidance and ensure that the equipment is operated safely and in compliance with all applicable regulations. Regular training on the safe operation of induction heating equipment is essential for all personnel who work with the equipment. The training should cover topics such as electrical safety, hazard identification, and emergency procedures. By providing adequate training, you can help prevent accidents and ensure the safety of your employees. When selecting induction heating equipment, consider the specific requirements of your application. Choose equipment that is properly sized for the load and is capable of delivering the required power and frequency. Ensure that the equipment is compatible with the materials that you will be heating. Consult with a qualified supplier to determine the best equipment for your needs. Proper maintenance of induction heating equipment is crucial for ensuring its long-term reliability. Follow the manufacturer's recommendations for maintenance procedures and schedules. Regularly inspect the equipment for any signs of wear, damage, or corrosion. Replace any worn or damaged components promptly. Keep the equipment clean and free of debris. By following these maintenance practices, you can extend the life of your induction heating equipment and minimize the risk of downtime. In addition to the disconnecting means, other safety devices may be required for induction heating equipment. These devices may include overcurrent protection, ground fault protection, and temperature sensors. Consult with a qualified electrician or engineer to determine the appropriate safety devices for your application. When installing induction heating equipment, consider the location of the equipment. Choose a location that is well ventilated and free of obstructions. Ensure that there is adequate clearance around the equipment for maintenance and servicing. Avoid locating the equipment in areas where it could be exposed to excessive heat, moisture, or corrosive substances. When working with high-frequency induction heating equipment, be aware of the potential for electromagnetic interference. High-frequency currents can radiate and interfere with other electronic equipment. Take steps to minimize electromagnetic interference by using shielded cables and enclosures. Ground the equipment properly to provide a path for the high-frequency currents to return to the source. If you experience any problems with electromagnetic interference, consult with a qualified expert. They can provide guidance and help you resolve the issue. The safe and efficient operation of induction heating equipment requires careful planning, proper installation, and regular maintenance. By following the guidelines and recommendations provided in this discussion, you can help ensure the safety of your personnel and the reliability of your equipment. Always prioritize safety and consult with qualified experts when needed.